So why we are having now, to recapitulate it, why the stability studies are necessary? They are necessary to study the chemical degradation of the product. Chemically, the degradation of the product. The product may be a tablet or a capsule or a syrup that leads to the lowering of the concentration of the drug in the dosage form. This is the one we want to study it to make the establishment of the shelf life and expiry date and storage condition and container closure system by studying their content present in the package. Another one is the drug is present, is it going to be sufficient? No. It is converting it to a toxic product that may cause the death of the person who is taking the product. It may not be the death, the toxic product may cause the skin rashes. Sometimes it will be having a small rashes onto the skin. Sometimes it may be resulting into the another complications. That will be causing a confusing situation where even doctor does not know what is going on with the patient after taking particular tablet. It will create a more complication than our own disease. Because a disease already known, we can treat it, but this is unknown disease with the toxic product. It is very difficult to cure. Because it is arising due to the chemical degradation of the active ingredient. That active ingredient is converted and broken into the toxic product. The toxic product is causing a damage to the body. This is the reason we need to study the stability studies. Okay. So what the advantage we are going to gain with the stability studies? So by your studying the stabilities, we have got the chemical degradation studied. We need to establish the toxic product. And the advantage is the assurance to the patient that what he is taking is not going to cause a damage to him and he is going to get the cure of the disease. This is one. Another one is an economical consideration, like if you don't do that and launch the product and you will be asked to product recall and close your company and you are getting the product failed so many times, it is not actually economy to the factory. If you are doing everything is right and you are going to sell that and you are going to earn the money, otherwise it is a loss. Not only these two, it is a legal requirement. What is a legal requirement? It is bound to be present without any skip. It should be done by the factory. I repeat, you are going to enter into the pharmaceutical jurisprudence in nearby course. You are going to see there are two types of the requirements which you are going to meet. One is a guidelines, another one is a legal requirement. Guideline is the one that will be giving a guidance to the patient or the factory or a people, so that by following them they will be safe. But they are not mandatory. They are required to be used for the goodness of the conditions and the situations. Whereas the legal is the one which is mandatory. It means you are supposed to do it. It means the stability testing is mandatory. It is not like that you can skip it or nobody will bother about it like that. It is a legal requirement. You need to do it. If you don't do them, you cannot release into the market. That is the reason you are going to have these advantages of meeting the legal requirement to sell your product. You are going to earn the profit. You are going to gain the confidence of the patient by using your product. They are not getting any ill effects and their disease is getting cured. Because of that reason, we are doing stability studies. What will happen if you don't do the stability studies, or what will happen if the unstable product are present, instability present in the drug? That is actually what the question that will motivate us to do all the stability testing and doing it regularly in a perfect manner. The first point in this, if the instability of the drug is present because of either it is an improper container closure, improper storage condition, or it may be a chemical degradation or a physical change, or it may be a toxicological effect which we are getting by the breakdown of a product. So these are all the things which is causing a damage. The first thing is the loss of active ingredient is biggest problem. It means whatever the active drug is present, if it is not stable, it is getting reduced from its original strength. Say for example, we are claiming that our product is going to contain aspirin, and aspirin is an ester. It is getting cleaved to its original carboxylic acid and the alcohol. So the original carboxylic acid may not be having the similar aspects of the aspirin, even though it is not problematic or toxic. In this particular case, your disease of a particular requirement of a blood thinner of a aspirin which is having, but it may not be possessing when it is getting degraded to the salicylic acid. Aspirin is a acetyl salicylic acid. So the salicylic acid, the acetyl ester is getting cleaved by the hydrolysis, and it will be changing its functionality, even though it causes the toxic damage. Similarly, oxidation of adrenaline, it may not give the toxic effect, but it will not treat the disease. Because of that reason, we are going to do the study of the stability to see that whether the drug is unstable or not. They are more prone to get oxidized, and they are getting hydrolyzed, or maybe getting affected by the light, or it may be getting affected by the temperature. We are going to study. Another one is loss of vehicle. The drug is safe, it is present, is it okay? No, if your container is containing a syrup or anything, it is containing a solvent, even the solvent is getting evaporated. Say for example, from your oil in water emulsion, that is a cream emulsion, it is present in a ointment tubes, you are giving it, it will become hard and it will not spread onto the skin and it won't work. So the vehicle what you have added, it is giving a semi-solid consistency for proper spreading onto the skin, it will lose. So even though the drug is safe and the drug which is present in the cream is intact, but the solvent is getting evaporated, that will cause the damage. We need to protect that also. Similarly, the evaporation of the alcohol from the alcoholic mixtures, it will cause a precipitation of your product and make your product not working. So not only the drug, the solvent evaporation is also going to have an impact. That is the reason we recommend well-closed container. Well closed. Otherwise, the evaporation will cause the damage. Another one is, even the drug and the solvent is present, but it may cause the loss of content uniformity. When your content is uniform by having a modification in your system like creaming and cracking or a sediment formation. So this is actually what will have an impact onto your suspension and emulsions. So it will have the drug distributed not properly. Because of that reason, we are going to have the failure of the product. So we have already seen in the previous classes of the suspension, if it is forming a hard cake, it is worth not to use. Similarly, creaming of the emulsion, that will cause the separation of one layer and make one layer concentrated and rich in drug, another layer is very poor in drug and concentration is very low. So this is actually what the impact onto the content uniformity also going to damage our product efficacy. Another one, you leave the content, you leave the vehicle, you leave the drug, but the loss of elegance, look of the product, it is also going to cause the damage. So what the look of the product which is going to damage, like fading of a tablet which are dark in nature, it is becoming dull. And colored solutions are appearing when the solution is required to present as a colorless. So what it will give the idea that either increasing the color or decreasing the color, it will misguide the patient that identity is not same. I am taking something else tablet, not the regular tablet I am taking it. Even though it is going to function, it will impact his psychological balance, that it may not treat the disease. That is going to cause the problem. That is the reason we don't know whether the color change is having an impact of all the four above present, or it is having a complete safety, but still we cannot use them in the market. We need to bother about that particular change in the color also as an important. It is going to safeguard the company image and patient's confidence. Otherwise, they are going to lose the customer and they are getting defaming effect. The reason is, in the description of your any formulation, we are going to have this color and the state of matter. Whether it is, we are saying that description is a colorless liquid. If it is having a light yellow color liquid, the description is failed, you cannot release into the market. Similarly, you are going to have a dark brown tablet. It is appearing as a light yellow tablet. Then description is failed, you cannot release into the market. So this is actually what the impact of elegance also having an impact on our business. Reduction in the bioavailability. It is appearing correct. Content uniformity is excellent. Vehicle is same and the drug is present as such whenever it is present, and I am tested with HPLC and GC and everything is perfect. But it is not available to the system. When I am taking the tablet in the morning with a glass full of water, in the evening it is coming out in the next day, or it is going to the gutter. And what is its use? It means it is having everything, but it is not available to the system. Why? The aging of the tablet resulting in the change in the dissolution profile. It is not getting dissolved. It is present as the intact tablet. It will go to fecal matter. It won't work. Then also it is not useful. So the reduction in the bioavailability may be caused by the aging or keeping in the self and getting reduced its content, and it may not function. It may not work. So even though the above parameters are met, but it is not working, it is not good. Not only all the above are met, even though it is working properly and bioavailability, but it is having a toxic material present in that. The breakdown product from the degradation, it is causing a side effect. Then your product is not worth to consume. Because of that reasons, we are going to have all these studies keeping under the control by establishing our stability protocols and following them and testing them and providing the evidence to the regulatory bodies. They are visiting the factory to see that our journey of our stability testing proper or not. Because it is a legal requirement, everything will be tested and inspected by the inspectors. Say, for example, some of you may be becoming a drug inspector after this particular B-Pharmacy course. You are going to inspect the factory, taking the sample. Either you test for the active ingredient or vehicle presence or content uniformity or elegance, or it may be availability or toxicology. Any toxic effect is present in any parameter which is not meeting properly, then you can sue that company that you cannot sell that particular product into the market because of the so and so reason. This is actually why it is been that much strict, and it has been given power to them. A person who is coming as an inspector, because it is impacting the health of the patient which is present in the society, and it will cause the damage to the health of the people who is prevailing in that country, in that particular country. So they are very hard enough, and the rules are in such a way that they can do pre-established norms of any fines or effects which they are going to have, to the extent like imprisonment, seizure of the product, or closing of a company. Anything can be taken. So this is actually what it is having an highest impact onto our entire journey of a formulation manufacture and API, that is a pure drug manufacture. Now coming to the what factors that affecting the stability? First is environmental factors. The environmental factors, preferably oxygen. Obviously it is present in the environment. Water, it is the humidity which is present, it will cause the damage like hydrolysis. And the light which is present in the environment, of course we are going to use in the day and night. In the daylight the sun is present, sunlight. In the night time we have got our lamps which are present in our home. So that will change the stability of product. So these are all the impact. It is going to have an impact. And obviously our temperature. So this environment is having some temperature where we are putting our product. So that will cause the damage. These are the factors which we are going to study in our curriculum. Of course, there is a second parameter which is going to give an impact, is called as a microbiological contamination by the invisible organisms which are entering into our product and damaging our product or cleaving our product, like bacterial contamination, fungal contamination, or viral contamination, which is going to cause a damage and it will impact the stability. You might have already studied in the microbiology in the third semester. So where you have tested your bacteria growth, anaerobic and aerobic, and motility of that particular bacteria, and gram staining, and you have already seen the sterility testing, and whether what is the zone of inhibition of your antibacterial preservative what you have used. So these are all the so many approaches are present to study microbial contamination. This part is not present in our physical pharmaceutical you have already learnt. Another parameter which is going to give the effect in the stability is container and closure. Of course, we have already studied in pharmaceutical engineering material of construction. We have got metals and non-metals. In the metals, we have got so many like ferrous and non-ferrous. In the non-metals, we have got a plastic, rubber, and glass, everything. We are going to use them for the container and closure. So these containers and closures, which are going to take away our drug product by the interaction with them, and which is going to cause the damage. So we need to study their suitability for usage. So that will affect the stability of the product because the container which is having a amber colored, that will reduce the effect of the light onto the product. If it is light, it is a transparent container, it may degrade very faster when compared to a rough container or a hazy container which you are going to give, where the transmission of the light is not there. A plastic product may hold, sometimes a glass product may be having a non-adsorbent in nature. So we need to study their impact onto our product safety, and the stability of the drug which is present in the formulation will not be getting affected with microbiological terms which are present invisibly in our environment. Is going to give an impact because our product is going to contain a sugar, or it may be a water that is good medium for the growth of material. So you may be thinking that, sir, I am going to control if I am using a drug like antibacterial or antibiotic. This I am taking for the treatment of the disease. So that will kill the product. So why should I maintain the microbiological contamination in the antibacterial or antibiotic? It is going to kill, getting killed in that one. So this particular doubt you may be having it for every product we are launching, whether it is antibacterial, it should be having a devoid of microbial contamination. It should not have. Why? Reason is it may kill the bacteria which are having a life in nature, but a spore may be present, it is having a sheath around them. They may not be getting affected with this particular antibacterials, but they will be converted into active microorganisms when in the body. When they are going to have a dilution effect, they are going to get active and they will act. It means we are going to test them and we are going to use a proper material without any microbial contamination, even the product which are having antimicrobial activity. I hope you understand the concept why you need to test them. The antimicrobial antibiotics also, for the microbiological contamination, we need to study. So these factors which you have already learnt in the microbiology, container closure system you are going to study in the pharmaceutical technology in nearby course, and drug delivery system, NDDS, which you are going to study, and environmental factors which we are going to have now. And in our practical, we are having a practical based on the impact of temperature onto the stability effect. So we are going to study that in the laboratory, which we are going to have, and to predict which kinetics are falling, whether it is a zero order or a first order, or it may be a second order kinetics which are falling, by studying the effect of temperature onto your product and estimating its rate constant. Accordingly, we need to estimate off-life and shelf-life and predict the expiry date. So this environmental factor measure is temperature, light, and the moisture. Of course, we are going to have a impact of oxygen also, and this oxygen is a chemical means of affecting the stability, and we are going to study that also. So the temperature, light effect, and moisture and oxygen, which are present in the environment, which we are going to study in this particular curriculum, what we have got in the 5th unit of physical pharmaceutics 2. And we are not going to see the impact of the light and the oxidation, but we are having a practical onto impact of a temperature, and without studying a temperature, we are going to study the effect of moisture, that is the water, on the hydrolysis, and we are going to see the stability study, and we have got a practical. It means these two factors which we are going to study, and we are going to have a major experiment in the practicals also. It It means in the theory and the practical, we are going to have this particular parameters coming. The first one is the temperature. This is the practical which we are having in our case. So each parameter which is having an impact separately, which will be having a study, and sometimes you are going to getting a major question at the time, 10 marks, all the 4 we need to write it. Sometimes they will be asking your photo degradation pathways and the temperature effect onto the stability and your hydrolysis effect, oxidative phenomena for the stability separately also. Sometimes they will be asking the separate 4 factors separately as 5 marks question, and they will be having a list them and define them and classify them, something like that in the 2 marks question, and all together you may be getting in a 10 marks question. Generally, we are doing a temperature. Whenever you are calling it as a temperature, there are 3 types of storage temperatures which are prevailing in our pharmacy. I would like to brief them so that you will be having an understanding that what is my temperature range where I need to study the practical. So the first thing is the room temperature. Generally, it is changing in our India from 10 to 40 degrees centigrade. So don't take the consideration of the deserts and Jammu and Kashmir, where maybe less than 10, but this is the range which are having, say, take it into consideration as 0 to or -5 to 50 degrees centigrade. In peak summer in Ramagundam or Kottagudam, we are approaching to even 50 also. So this is actually what the room temperature is existing. But generally, whenever we are calling it the room temperature, it is 25 degrees centigrade. 25 degree centigrade. Whereas our body temperature is 37 degrees centigrade. It is fixed. Whenever it is not mentioning any temperature, it is a room temperature is RT as a 25 degrees centigrade. Second is cold temperature. The third is a freezing temperature. That is a freeze storage. Okay. So it is actually a room temperature is up to 30 to 25, and the cold temperature or refrigerator storage is 2 to 8 degrees, and the freeze storage is -20 to -10. So -20 degree to -10 is the freezer. It is present in the freezer, and we have got a further storage conditions. Like this is actually what is existing in our pharmacy stores in India. What the Pfizer vaccine which is available now, you are listening that it is having a storage temperature of -40. So this is not available in pharmacy stores of India. It requires liquid nitrogen or liquid solid carbon dioxide to store them. Otherwise, they will not be getting stored and they are not going to be stable. Only the 3 conditions which are prevailing in India. So we are going to supply our products. In these conditions only they will be stored. So we need to make the product. If it is not present in these conditions, it means that you need to alter your excipient or change the dosage form, or you need to change your container closure, or you need to do some modification to fit your product. They are going to be stored in these 3 conditions, because storing it lesser than that is very much problematic and highly costly. Because of this COVID, it is inevitable and there is no other option, and it is being followed as -40 also. It is approached and it is being used, but it is not suggested to have the economical viability for the poor countries, and some country may not be having that facility. That is the reason we need to have a target of these 3 temperatures. Another one is the light, which we are going to study having an impact. The shorter the wavelength and more the energy is absorbed furthermore. So it is going to have a decomposition. Generally, our visible light is present in the range of 450 to 700 nanometers, whereas the UV light is having 200 to 400 nanometers. So in the shorter the UV range, that is going to have a greater effect when compared to visible light, and UV light is having a more impact onto the decomposition. So we are going to restrict the UV rays to enter into our product, which may be in our sun rays, by using an amber colored container, or using a non-transparent container, or it is a plastic HDPE bottles, so that the degradation by the light will be prevented. Here our selection of a container closure and type of color and the type of container closure cap system we are going to see. So various sources of the light which are present, that are including sunlight, or it may be metallic sodium lamps or metal halide lamps, and fluorescent lamps like your tube lights which are present, and other indoor lighting sources like your LEDs. So they are all going to contain different wavelengths. These different wavelengths which is going to enter into our drug product cause the photolytic degradation, enhances their pathway and degrade the drug and make them not suitable for use. We need to protect it. So these reactions can be reduced by the exposure to the photolysis emitting in the range of 290 to 800 generally region. So we need to avoid these reactions because this is the region which is prevalent in our environment. So we need to study it. So this is actually what our range and the scope of the study for the light, that is a degradation of the product by using a light. Most of the times we are having a UV range in the range of 50 to 400 nanometers and visible light 400 to 750 nanometers, and IR is 750 to 10,000 nanometers, which are having, and we are having a energy, if you are seeing it, and it is going to approach to the top, which is having a highest energy, kilocalories per mole, when it is coming down, which is having in the range of 36 to 1 kilocalorie per mole. So we need to have the lower wavelength which is required to be prevented.